Indian Railways is the lifeline of the nation. Phenomenal increase in traffic density combined with increase in speed and axle load of the trains has necessitated adoption of modern track structure and mechanized maintenance. Ballast plays a very important role in the track structure. It transfers and distributes the wheel loads evenly on the formation. It provides an elastic resilient medium to the rolling stock so as to provide smooth riding comfort. While transferring loads, it provides resistance to vertical, longitudinal as well as lateral movement of the track. It acts as a medium for track geometry correction and provides an effective drainage. While performing these functions, ballast gets contaminated due to various reasons such as packing, impact of traffic, abrasion or weathering action, fine particles coming from subgrade because of mud pumping or coming from surface because of droppings from passenger trains or due to wind, water, etc. The contamination affects adversely the functioning of ballast. It results in reduction in elasticity and also affects the drainage. All this results into reduction of load carrying capacity of the track. Caked up ballast makes the track geometry correction difficult, which in turn requires more frequent attentions to be given to the track. To remove all these ill effects, ballast needs to be cleaned periodically. Traditionally, the cleaning of ballast is done manually. However, manual cleaning of ballast has many disadvantages. For example, quality of the work is poor, progress is less, it requires long caution orders, and sometimes unsafe as the cleaning is done between the passage of trains. It also causes damage to concrete sleepers. To overcome these disadvantages, ballast cleaning should be done mechanically with the help of ballast cleaning machine. This machine provides a complete solution for effective and efficient ballast cleaning. This machine is capable of cleaning ballast from plain track as well as points and crossings. Basically, the machine excavates and picks up ballast by means of a cutter chain and carries it to a set of vibrating screens where the muck is separated and thrown out by chute, and the clean ballast is transferred back to track. Important assemblies of BCM. 2 air-cooled diesel engines, one each at the front and rear end, are the main source of power. The front unit powers the conveyor belt and hydraulic cylinders, as well as work and transfer travel. The rear unit powers the screening unit, excavation chain and transfer travel. The excavation chain is driven hydraulically with the help of a gearbox. It consists of 280 mm high scraper scoops, each with 5 scraper fingers. The chain speed can be adjusted between 2.4 and 4 meters per second in 4 main settings. The chain guide can be lowered up to 1000 mm below top of rail. The cutter bar has a standard width of almost 4000 mm and can be extended on the left by one insert of 500 mm wide and on the right by one or two inserts looking in the direction of the work. The excavation chain takes the excavated material directly to the screening unit. Removal of the material from the ballast bed and the action of the chain transferring the material to the screens sufficiently breaks up the excavated material for its proper screening. The free oscillating vibrating screen has a hydraulically powered linear vibrator. The 3-grade screening unit has a total screening surface of 30 square meters. Oversized ballast gets dropped through chutes directly onto waste conveyor system. The screens have mesh sizes of 80 mm, 50 mm and 36 mm square. Hydraulically adjustable baffles control the ballast flow onto each screen. Automatically operated stop flaps at the runoff end of each screen enable the ballast to be held on the screen if work is interrupted. The entire screening unit can be hydraulically adjusted on locations where there is super elevation so that the unit remains in horizontal position. The lifting and slewing device is positioned near the excavation chain. 4 roller lifting tongs which grip under the rail head carry out the lifting and slewing work continuously. Lifting of track up to 250 mm and side slewing up to 200 mm in either direction can be achieved. The device is particularly useful for reducing the excavation depth by lifting or slowing the track to avoid obstacles in the track. Cleaned ballast reaches the track via ballast distribution conveyors located directly behind the excavation chain and gets distributed evenly across the entire ballast profile. A plow grader is positioned behind the ballast distributing device which sweeps off any ballast lying on top of the rails. Below the screening unit, the muck is passed on to a waste conveyor belt and led on to a hydraulically adjustable temporarily lifted up to 100 mm by BCM itself during working. Since the cutter bar moves continuously below the track, the machine cannot work if there is any lateral or vertical infringement. For such locations, either some special preparations are required or work has to be done manually. Since the setting and closing time of the machine is longer, ideally a block of 4 hours is necessary. However, at least a minimum block of 3 hours is required. Adequate arrangements for supply and training out ballast should be ensured. While working in LWR territory, provisions of Manual of Instructions on LWR should be followed. Trench for cutter bar should be made and cutter bar should be placed in the trench. Field survey should be done to fix track profile. Infringements to be removed before machine block. This is important to avoid undue problem during block working. Recoupment of fittings and replacement of broken and damaged sleepers should be done. Guard rails, check rails, wooden blocks, joggled fish plate and any other obstruction should be removed in advance. Traction bonds should be removed or adjustment should be done to traction bonds so that these do not infringe with the machine working. After the machine has reached the site, mode of the machine is changed from driving mode to operating mode. The cutter bar is attached to the excavation chain and the chain is tightened. The chain unit is first run empty to check its integrity. The waste conveyor belt unit is unlocked and placed to suitable position. The distributor belt is placed at proper location. Screening is started after ensuring all safety measures, pressure gauge readings, etc. While utilizing the BCM in a section having multiple lines, a temporary caution on adjacent tracks by way of suitable speed restriction and continuous whistling should be imposed so as to ensure the safety of the BCM working staff. This is necessary because a lot of dust and sound is generated while working of the BCM. Apart from the operator's cabin, the operating functions The section engineer P-way should check track parameters, namely gauge, cross levels and alignment immediately after screening. Checking and tightening of loose fittings should be done. Broken fittings should be replaced if any. Deficiency of ballast should be recouped. Proper tamping and consolidation of ballast between the sleepers should be done. Along with the BCM, one tamping machine, generally Duomatic, and DGS machines are used which work behind the BCM. These three machines together make a complete unit which carries out the ideal and most effective ballast maintenance cycle. With these three machines working in tandem, the block can be cleared with a speed restriction of 40 km per hour. Refixing of guard and check rails should be done. On an average, the machine can clean plain track up to 140 to 150 meters per effective working hour. Manpower requirement for working a BCM is as follows. Track machine supervisor, machine operator 3. Track machine maintainers 3. Track machine helpers 4. At any given time, the machine should have minimum 3 sets of cutter chains, sufficient quantity of round sharp chisels, chain bolts, conveyor bolts, buckets, etc. The diesel requirement of the machine is 50 to 60 liters per working hour. Since the transfer travel can be powered by either of the engine, in case of failure of any one engine, the other can be used to bring the machine to stabling siding. In case both the engines fail, to tackle such a situation, an emergency backup system is provided on the machine, which is operated by a battery and not powered by any of the engines. This emergency backup system can be used to lock all open systems of the machine, and then the machine is to be towed by another source of power. Cleaning of ballast by BCM ensures effective and efficient cleaning of the ballast to required depth. In view of the distinct advantages, BCM should be used extensively in the modern track structure.